Hey, okay, everybody. Welcome to week 10. It's nuclear week, so what I want to do first, just briefly, is go over summary 4. I picked summary 4 because it's about nuclear energy. I also wanted to thank, there was a student who let me know that there were a few of the assignments down the Moodle shell were not exactly in the same order as the syllabus, but I also want to take this opportunity just to review the syllabus and let you know that the
Problems at 2 and 3?
yeah. So again, I'll just say that I apologize if the Moodle shell doesn't. I think everything is in the Moodle shell and it's in order. It might not be exactly in week by week order. So, but if anything, and I think what I noticed or a student pointed out to me is that exam 5 was sitting there in last week's shell, but it wasn't available yet. So that was a little point of confusion. But when in doubt, please do refer to the due dates at the end of the syllabus. So summary 4 will be due at the end of this week. It will be late at the beginning of next week. So, as we just mentioned, summary 4 is not as challenging as summary 3. I know a lot of people are still working on it, and I'm willing to grant exception or extensions on summary 3. So don't sweat that too hard. Let's just take a look at summary 4 right now while we're thinking about it, but and then exam 5 will be next week, and then you can see the 2 more problem sets, summary 5, another exam. Oh, another student also asked me about the final. There will be a final. We treat it as a bonus final. You don't have to take it. If you've done really well on your exams 1 through 6, you can blow off the final. There's some pretty cool problems on it. I encourage you to take it, whether or not it counts towards your grade. I'm hoping that you just sort of enjoy the challenge of learning and thinking. So, and that's really what the exam is. It's just kind of some cool problems that get you thinking and send you on your way for 102. But when in doubt, please do refer back to this very last portion of the syllabus for the overall due dates. Okay, so let's just take a quick look at summary 4. Print it out today, start reading it, share some thoughts, share a draft on the summary 4 forum by next week. Let me just get down to it here. Okay, so Wang and Chen, nuclear reactors in China. And again, when you're writing your summary, what you're going to do is first paragraph or so, first or second paragraphs. Let us know what the questions are. What questions is the paper trying to answer? Put something in the reader's mind in terms of what are these guys trying to answer. In the second paragraph, dig into some of the numbers. You can see that there are some nice numbers in the abstract, so be quantitative. Again, it'd be nice to use some type of it wouldn't be nice. It's essential that you use at least one equation in your paper. Let's take a look and see if there are any here. This paper does not lend itself all that well to equations. If you want to, though, what you could do would be to say, I'll just give you an example. You could say that Japan's nuclear industry was relatively linear from the years of 1970 to 1990, and based on my linear model, they built approximately X reactors per year. And maybe it's 1, maybe it's a half, whatever. That would be a reasonable use of your quantitative skills on this. You could also say, the United States, by contrast, was building this many reactors per year, and now they've tapered off to a lower number. So Second paragraph, be quantitative, let us know what's got. And then you might say, oh, China, on the other hand, was relatively slow, but now is really taking off at a rate that is comparable or maybe exceeds that of France or the U.S. So, look at this little graph as sort of an MX, Y equals MX plus B chart, and you can call it good on that. Okay. And then I think I heard Tim mentioning this earlier, and I think it's a great suggestion. That third paragraph would be sort of your own view of what transparency might look like in the nuclear industry. Does it mean that there's like cameras on the thing 24/7? Do we know exactly where all the uranium is, the plutonium, the thorium? Do we know who's making money? Tell us what's most important to you. Is it public safety? Is it some kind of corruption? Is it transport of hazardous fuels? So, tell me in your own words what transparency means.
With this graph that we have right here,
yeah,
are we led to believe that every country's line continues on through 2010 and 2020, or is it that China is the only country that is currently building nuclear reactors?
Well, that's a great question. So on this figure, similar to what you've seen on summary 3, you have discrete data points. Each one of these points is a single reactor being built. So those are discrete events that have been measured. The lines are linear interpolations of the data. So no, what this means is 1993 is the last time a reactor was built in the United States.
Okay.
Yeah.
Okay.
The dotted line shows China's intended growth, production, fabrication, what have you. Yeah. And the textbook has some great data too on peak uranium, if you will. We've talked a little bit about peak oil, peak coal, peak natural gas. Uranium-238, there was a finite amount of that, well, 238 and 235, a finite amount of those two isotopes of uranium on planet Earth 3.8 billion years ago, and we're not getting any more. I mean, those fuels themselves are becoming less and less accessible. Less they decay. I mean, it just decays on its own. And if you remember, well, you'll see in 102, we get into Shramsky, and he talks about the total amount of biomass, including all surface biomass, as well as sequestered biomass. He also talks about the total amount of nuclear fuel available on the planet, and how it's just there's only so much. Once you use it up, it ain't coming back. Okay, so take a look at this paper, and I think what you'll find it's a little easier. It's a little more conventional, not as difficult and challenging as summary 3. But I also want to reiterate that summary 3 is going to give you the quantitative skills that are going to be valuable to an employer. It's going to be something that's going to allow you to look at previous data trends, do some extrapolation, do some prediction, and say, here's where I think the solar PV, the solar thermal, the big wind industry is likely to be in the future. And you could do it for a number of installations. You could also do it for the costs or the prices of various energy sources. And then near the end of this chapter, and also at the end of 102, we'll start to get into environmental costs. We'll get into pricing carbon. Once those two things come online, renewable energy looks even more attractive if you look at the so-called true costs of climate change. So, all right, quick break, and then we'll get into summary 3, because I know there's some questions on that, and then we'll start looking at chapter 10.